With every new release, PostgreSQL gets better at addressing the needs of developers, system and database administrators. If you're part of a dynamic business with high quality services and products, Postgres can be a candidate technology for database management. In this talk, I summarize the practices, the methodologies, and the techniques that we have been successfully adopting at Second Quadrant Italy in the last 3 years. So, good morning. I'm Gabriele Bartolini, and I'm the Managing Director of Second Quadrant Italy, and I'm also a member of the PostgreSQL community. And today, I will speak about managing PostgreSQL in a DevOps environment. So before we start, I want to clarify one thing. I will be speaking about the vanilla PostgreSQL, so the community released and distributed product. So there's only one PostgreSQL, and that's the community PostgreSQL. The name is PostgreSQL, but you can also use a synonym, Postgres. So you are okay to use both names. Don't use a different one, because otherwise, even if you write a post to the mailing list of Postgres and use a different name, you won't be taken seriously. Okay? So your posts will be immediately trashed. So either stick to PostgreSQL, or for Italians, it's better to use Postgres. But don't use Postgre, because my hair would become like even more hairy than now, okay? So I started to use Postgres in 2000. I was using MySQL as well, but then when I tried to switch to InnoDB, I lost all my data. So in 2001, I switched completely to Postgres. So Postgres has become my only choice in 2001. So we've been together for 15 years almost. So these are a few milestones of my life. Some regard IT, some don't, like world champions in '82. Italy became world champion in '82. Then in '84, I got my first Commodore 64. In '95, I touched for the first time Linux, Apache, and I started to build my first CGI applications. 1999, my first open source contribution to HTDig. I don't know how many of you use okay, I was part of the HTDig development group. Postgres in 2000, 2001, I moved to Australia. I lived there for a few years. I studied and worked there in the web analytics sector before it was known as web analytics anyway. So came back in 2006 to Italy, and I got to know Scrum. The first time I started to use Scrum heavily was in 2006. In 2007, I organized the first PostgreSQL conference in Europe that was held in Italy, and founded with other members the Italian PostgreSQL user group. The year after, I founded PostgreSQL Europe, which is the association that promotes PostgreSQL throughout Europe, and started the business with Second Quadrant Italy. 2012, I started to use DevOps, and in 2013, Kanban. How many of you are familiar, for instance, with Kanban? How many of you use? Okay, good. And I imagine all of you use DevOps, are DevOps practitioners, or I'm a DevOps practitioner who's, okay, so you're new to DevOps. Good. So Second quadrant is the largest team of PostgreSQL experts in the world. We are leaders in recovery, replication, scalability, and performance of PostgreSQL databases, having written about more than 10% of PostgreSQL code. We have focused on training and services as we have adopted an open source model. So we deliver 24/7 support under the follow the sun methodology with 4 6-hour shifts. We have also guarantee of resolution and 15-minute response time. Anyway, let's start with today's talk. The first part of the talk will be an introduction to DevOps, given that most of you are not using it, so it's good. So DevOps is a neologism. It's a new word, and it's a combination of 2 words. The first one is dev, which stands for development. In the classical view of an IT firm, development department mainly focuses on its inputs and produces their outputs. So developers, what do they do? How many of you are developers? What languages do you use? Python. Java? Okay. Java. Also PHP, I imagine. Okay. Ruby. So, as developer, you write your own stuff, you have your ideas, and you produce programs. So, and you're happy about it. Okay, so you've done your job, your program works on your laptop, and that's it. As a system administrator, you work in a very similar way. You have your own inputs, so you have your ticketing system, you have requests, and you produce your output. You close the tickets, and you manage, for instance, your proxy, and you block everyone who you don't like from accessing the internet, so you can blackmail everyone. And you're happy about it, but there would stand a wall between the 2 departments. I have experienced this situation in the past. How many of you have experienced this situation? Or probably experienced that every day? Well, now I don't experience it anyway, every day. So basically, you have 2 sealed compartments that seldomly communicate with each other, very rarely cooperate with each other, and are usually not integrated into each other's streamline. So they work separately. They don't communicate. So all of these leads to misunderstandings. And for example, you have a programmer that's been working for the last 6 months to release a new feature. So he's been working, or she's been working by herself, and after 6 months, he writes the code. It works on the laptop, and says it's ready to go live. So commits everything, send the tarball to the system administrators, and flies to Hawaii for 2 weeks for a well-deserved holiday. What happens is that system administrators the following day receive the email with the tarball, and they say, hang on, but he has used that library that we don't support. I mean, we are already using this version, and he's still using that version. It's not compatible with our systems. And nobody asked us about backup policies or security policies. And finally comes the boss, because the boss doesn't see anything and says, hang on, but how long it's going to take for you to deliver that bloody feature? So he gets angry, and you know, the devs and the ops start organizing in two different clans. So they start to fight with each other. All of this leads to work hatred. And, you know, I want to say a few things here. Work hatred. I mean, every day when I go to work, and also because probably I work with open source software, so I feel like we can do pretty much everything. I think what makes us go to work every day is the passion we have for this work. At least this is my case. I mean, I really love this job. I really love what I do. If I start hating my job, waking up every day would be such a pain. So all of this is really, really dangerous in a work environment. Because we want everyone to be happy. We want everyone to be satisfied with the work they produce, especially if it's in a well-functioning team. And we all know that system administrators are much better than this. Okay? So, but in some cases, that's all they're there for, you know, and that's really, really sad. So, work hatred leads to a decrease in productivity. And there comes the DevOps movement. So the DevOps movement analyzed all of these and started to think the work environment as a single team with shared inputs and shared outputs. So instead of thinking locally, developers and operations have to start thinking globally as a single team, as a single company. So they all get the same inputs and produce something together, which is much bigger. So they can clearly see the goals. And this makes a lot of difference. If you haven't done it yet, I really suggest you read this book by Gene Kim, Kevin Bear, and George Spafford. In this book, the three authors describe the work in an ICT firm in three ways. Basically, the first way is the one that emphasizes the performance of the entire system. I want to quote this sentence because I think it's really powerful. Never allow local optimization to create global degradation. So how many times we have written or committed a change in a function, in an application, in a SQL statement without testing it, because it's late at night, I want to go home, I can't be bothered testing it. So I just commit the change and go home. The following day, you discover that that change broke production. So you perform local optimization because you couldn't be bothered. You just had to make that change and go home, but you created global degradation. When you think globally, this can't happen. The second way is a very interesting idea. It introduces feedback loops. So the work goes from developers to operations. That was the first way, but in a global environment. And then system administrators give feedback. So they work together. Even with pair programming. I don't know if you implement pair programming where two people work on the same task. It might be seen as a waste of resources, but it actually gives very higher outcomes. So, feedbacks, and the third way is the very innovative process that Gene described in that book. It introduces a continuous learning culture where you actually you take advantage of slack time. I mean, the time where you don't do anything. I mean, you're just waiting for work to come, and you experiment new things, because experimentation leads to mastery. So before things happen, you try new things, you try new technologies. You fail, because you try and implement that thing, you fail, you try again, until you actually succeed in that. And that's the three-way image that Gene Kim and others describe in that book. So I really suggest you read that book, because it's a story that narrates the events in this ICT firm. Some of the core elements of DevOps, according, of course, to my experience, are versioning. I mean, you can't work today if you don't use a source code management tool like a Git or Mercurial or whatever, or Subversion even. If it probably, I mean, I prefer Git, but anyway, you need to version everything and use the versioning system as the authoritative source of your code. You need to work together, as I said before. Make developers, QA engineers, analysts, and system administrators, database administrators share the same goals. For instance, in everything we second quadrant Italy, there's at least 3 people that manage one feature or one task. Okay, analysts, developers, testers, and of course the owner of the project that reviews the feature. You need to automate and be sure that you can repeat all the tasks you do in an automated way. You need to test everything you do. You need to monitor the system. So usually you use dashboards, or I don't know, probably we use Itinga, and we'll see it later, for monitoring. And you need to monitor your system and be alerted. So that's where system administrators must put a lot of attention, for example. The Kaizen culture. Kaizen is 2 Japanese words, basically, put together. And Kaizen means continuous improvement. So in our team, we need to grow. We need to improve ourselves. We need to learn new things every day, because we must love the job we do. And agile management. So this is, I mean, we've been adopting Scrum since the early stages of our company. But in 2013, we hired Dragos Dimitriou, who was the first Kanban practitioner that applied Kanban and that theory of constraints in an ICT firm when he was working for Microsoft. And in only 3 months, we reduced the lead time. The lead time is the time that it takes for one feature from the conception to delivery, from 16 days to 7.5 days. And now, today, we reduced that to 5.7 days. So when the client asks us for a feature or for a task, on average, it takes 5.7 days for it to be delivered. Before it was 16 days. And Kanban, this is our Kanban board. And Kanban actually, because we are knowledge workers, so we are used to work with invisible stuff, invisible tasks. What Kanban does is making these invisible things visible. So every activity is a post-it on the board. So that's the backlog. That's all the things that we would like to do. As soon as a task is commissioned by the client, it gets into the ready column, and then it starts advancing until it's delivered. So these are the tasks that have been delivered in that week. And at the end of the week, we summarize all the activities we've done, and this summarizes the activity that our team has done since the start of the year. So about 1,300 tasks we've done. And this measures also the distance between this green line and the yellow line you can't see, measures the work in progress. So the tasks that have been declared ready and haven't been delivered yet. Okay, so that measures the quantity of work that in that week was present. The goal of a Kanban board is to reduce the work in progress between ready and delivered. Because if we have too many things, we can lose focus. So we can lose track of the work we're doing, and we don't deliver stuff. Okay. Discipline that I really love it, because I can see the results every day, and the team shares the goal this way. So you can use electronic boards as well, or you know Trello or Linkit. They are the two more famous tools, but we prefer to keep it classical with post-its and continue like this. So this is how I see a DevOps team. I come from football, from soccer. So I've played soccer all my life. I've been a coach for kids. So I really see the importance of feeling part of a team. So I'm really lucky to be able to manage, to be the team leader of my team in Italy. It's a small team. It's not big. We're 8 people. So that means that it works even with small teams. And to me, this is a very good similarity, because I believe that, for instance, 11 Messi or 11 Ronaldo won't make you win a World Cup. But you need a goalkeeper, you need good defenders, good midfielders, good attackers. You need probably the best player in the world, but Germany didn't have the best player in the world, but they won the World Cup. So the message is that we have to work as a team, exploiting everyone's skills. So that must be the ability of the manager, to understand the skills of everyone you have in your team, and also work with the character and also social skills. It's an amazing job, and I feel really lucky about that. But having said this, you're probably wondering where a Postgres DBA fit in all of this. I mean, I've been talking about DevOps, but the talk is about also PostgreSQL. So how many of you are PostgreSQL database administrators here? So 1, 2, 3, 4, 5. Okay. How many of you already use Postgres? So, okay, who doesn't use Postgres? I'm not going to shoot at you. Okay. 1, 2, 3, 4, 5, 6. Okay. 7. Do you mind if I ask what databases you use?
SQLite,
mostly. Okay.
I'm a student, so
A student, you don't use database. Okay.
MySQL and MariaDB.
Okay, MySQL and MySQL. Okay, MySQL. So why are you here? Are you thinking of switching to Postgres? Okay, good.
I must go with my ops.
Your ops? Okay, so the pro. Okay, we'll try and make that happen. Okay. By the way, there's an article about moving from MySQL to Postgres on Planet Postgres. So if you go on www.postgresql.org, you see it on the right column today. I think it was posted yesterday. I haven't read it though. So a Postgres DBA perfectly fits in a DevOps environment. Why? Because his mission or her mission is to promote a database culture in the team. Databases are important. They're in everyone's life, even if we don't know it. But probably most of the apps you use have a database that collects data, manages data. So they're really used. They're everywhere. So a database administrator stands between developers and operations. You might have a database administrator in your organization, or it could be a role performed by both developers and operations. That's a very typical scenario we find. So a DBA, so if you are a developer and you dress the role of a DBA, you should work together with other developers on SQL. So promote SQL. So every week, get an SQL statement, because I bet that I can find an SQL statement you don't know. Okay? So there's heaps of SQL statements that really help you. So every week you choose an SQL statement and you have a meeting with your developers, like a 15-minute, a stand-up meeting. So, oh, you know that with common table expressions, you can solve these kind of queries. You can help them with database modeling, also with managing changes. So if you change a table, you add a column, the database administrator must know it, and developers, they have to work together. Explaining queries, monitoring queries. Promote the new feature of Postgres. PostgreSQL 9.4 is about to come out, so you can organize a meeting or work together with the community to organize a meeting where you present the new features. If you use geographical information systems, PostgreSQL has the state-of-the-art in terms of information GIS technologies. It's got an extension called PostGIS. So you can work with extensions and package your functions, and with testing. This is an example. They usually come to us and say, okay, we need to buy new hardware. My query, it's taking 1 second to do an update. I have to do 1 million updates. So it's going to take a long time. So I need more RAM. I need more CPU. And then I look it up. And it was an SQL problem. And I brought that to 1 millisecond, the query, just to give you an idea that how important it is to master SQL. If you are a system administrator, a DBA can help you setting up the PostgreSQL server. Believe me, setting up a server specifically for Postgres makes a difference. So if you work together, you can improve the performance of your server. Tuning, updates, configuration management, monitoring and alerting. This is important. We have selected at Second Quadrant Italy some core technologies that everyone must know. So we have selected these, but you might be using different one, but with similar goals. I mean, we use Git, we use Vagrant, we use Puppet, we use Jenkins. So with Vagrant, how many of you use Vagrant? Okay, so have a look at that, because you can create virtual environments, and by doing this, you make sure that development, testing, and production happen on an identical configuration. If you make Vagrant work with Puppet, you can configure these virtual machines so that they're really created the same way for each developer and for each person that tests and does QA of your features. For example, if you want to play with this, it's a very simple open source project that allows you to install very quickly Ubuntu with PostgreSQL 9.3. It requires Vagrant, VirtualBox, and Ruby. And installation is very simple. You clone, you type bundle install, etc. And with these commands, you can control your virtual environment. So with Vagrant app, you start up the virtual machine. Vagrant status, you control the status of the virtual machine. You can also create multiple virtual machines with Vagrant. So for instance, we use it to test Barman, which is a disaster recovery tool. We need a Postgres server, a backup server, and other servers. So the test environment must bring up at least one Postgres server and one backup server to do all the integration tests. Vagrant halt, you stop. Vagrant destroy, you destroy all the virtual environments you created. It works in a directory, so everything is beautifully placed in that directory. You can connect to Postgres using the local 5432 port, and you're actually connecting to the one in the virtual machine. This is the Vagrant file. And this is the Puppet manifest that brings up the PostgreSQL server. I'll speed up here, but you'll find all of these in the project itself. We use the Puppet Labs module for Postgres. pgtab is an extension that allows you to perform tests with a database, with a Postgres database. So you can, for instance, create a database and make sure that the database has the domains table, the stuff table, the sources table, etc. That the domains table has the ID column, and that column is also the primary key, etc. You can also execute queries and make sure that the results correspond to what you expect. And the good thing of pgtab is that it supports the test anything protocol, and you can tie that into Jenkins. So not only you can test your applications, you can also test your database structure and your database, basically. When it comes down to Postgres, these are some of the technologies we have adopted and we believe that could help all of you guys. You need an alerting tool. We chose Itzinga, but you can use Zabbix, you can use Nagios, you can use Splunk, you can use whatever you want. But you need an alerting tool for sure. If the database goes down, you need to be alerted. Okay? You need a trending tool. A trending tool continuously pulls metrics from your databases and is able to build graphs. So when something bad happens, you can look up at the trending tool and discover what happened immediately before that in terms of network issues, etc. So that's really important to have. Then we selected PG Badger for post-analysis of log files. But since 9.2, PostgreSQL has a very, very important extension which is called PG Stat Statements that allows you to query the catalog to see all the queries and what these queries have done in your database, and we'll see that. And you need automated backups. So let's start with Itzinga. Itzinga, for instance, this is an email that we receive after a service has been recovered. But through emails, you get alerted if something goes bad. But you can also use pushover, so you can integrate Itzinga with SMS, etc. This is a dashboard that says that everything is fine. It's all green. And this is Moonin. Moonin is a trending tool. Why? I mean, some people say, why don't you use a specific PostgreSQL monitoring tool? I mean, our approach has been to see Postgres as a component of a much bigger, much larger ICT system. So Postgres has to integrate itself in the big picture. So if your system administrators use already Munin, you integrate Postgres in Munin. You don't use a specific PostgreSQL monitoring tool. That's been our approach. Same thing with Itzinga. So if you speak with your system administrators, if they use Zabbix and they prefer to stick with that, just integrate Postgres into Zabbix or the alternative solution. You can see the database size growing up over time, the usage, the percentage of reads from the buffer, the blue ones, or from disk, the green ones. This is important. This measures how well the PostgreSQL buffer is used. And this depicts the connections to your PostgreSQL server. Then PG Badger. PG Badger, you feed the PostgreSQL logs to PG Badger. So every hour you get the automatically generated log files by Postgres. You can, we normally use syslog, and you make PG Badger read them, and PG Badger builds HTML pages with JavaScript graphs that help you control queries, errors. This is the percentage of, select over inserts, etc. So this is important because it's a post-analysis on logs that you do. With PG stat statements, you have the opportunity to perform real-time queries on your database. So, for example, you can ask what are the queries that have taken more time so far to be executed. And what PostgreSQL does is to normalize the queries. So if you have a parameter, a constant, it's substituted with a placeholder. I don't know if you use Oracle. How many of you use Oracle? Okay, this one costs a lot. Okay, this is free and open source. And with PG statements, you can also get to understand how many, what's the hit ratio of reads on shared memory rather than disk for a particular query. So you get to know if that query needs to be optimized. And that's just by querying the database itself. It's really, really powerful. For automated backups, we have written Barman, which is one of the most used disaster recovery solutions for Postgres. Why we think a DevOps team needs it? Because it protects from data loss, but also allows us to automatically generate staging environments from a backup. So we have a backup. Every week, we generate from scratch the staging environment. And why this is crucial for a system administrator? Why, according to you, this step is crucial? How many of you regularly test your backups? Okay, it's like you're not taking any backups. A backup that is not tested is not a valid backup. This one helps you automatically test your backups. It's a very good practice. PostgreSQL has transactional DDL, so you can actually write begin and drop table and then roll back. Other people would scare, that would scare the hell out of other system DBAs, but it doesn't for PostgreSQL users. Okay, you can say, okay, just kidding. Roll back, that's it. You can write schema changes, migrations. Ciao, Ale. Of course, you have to test all of these and make sure that you don't have locking contentions, because if I do it, drop of a table, I might create locks on other transactions. Extensions have been introduced in 9.1. You can actually simulate packages in a database. So an extension allows you to define your own data types, your own functions, operators, and tables. And you can specify versions and dependencies. So your work as a developer could just be, on a database administrator point of view, the execution of one command. Create extension my app, and that means installing in the database a set of functions, operators, tables, and data types all at once. If you use PostGIS, to install PostGIS in a database, you just need to type one command. Create extension PostGIS. That's it. It takes care of dependencies as well. And if you upgrade your application, you give system administrators and database administrators version 1.1, and in one single transaction, you can upgrade your extension in the database with one command. It's atomic. If there's a failure, it rolls back. And of course, you have tested that in your development environment and your staging environment. So when it gets into production, you're sure that it works. So pretty much that ends my talk for now. We've been through an introduction to DevOps with some core elements that I picked up. Some of the core technologies that we have adopted in second quadrant Italy, and you can use them as an example, and you can use alternative tools as well. For instance, we chose Puppet. You can use Chef. You can use Ansible. But we're really OK with Puppet. These are some of the must-haves for us when you manage PostgreSQL. And that's it. This is a definition, my definition of the work of DevOps. It is a work culture movement that fosters the creation of a prosperous and collaborative working environment focused on shared processes. Processes are really important. But you need the culture. Without the culture, you're not ready to adopt these processes. It focuses on team results. It's not about myself, it's about us. And professional growth, because everyone needs to grow professionally. So that's where we talk about single and individual results. Because everyone needs to grow and to improve. So is DevOps just about tools? No, it is not about tools. This is my tool, but of course you can say the opposite. It's about culture that helps you build your processes, because the team has to build the processes. They must not be imposed from the top. With the culture, everyone is able to contribute to build team processes. When you've got these two things, culture and processes, tools will come. So the team decides the tools. So that's the beauty of that, because it's well accepted, it's not imposed. We also talk about lean systems, they're also called pull systems. Because when I manage my staff, I never say, you have to do that. You know, this is the Kanban board, these are the things that I would like to be done. You pick, when you're ready, when you have time, the task you want to do. And if you work, I work with Postgres. I hope many of you will continue working with Postgres and start working with Postgres. Because as a real open source project, so it's a real open source project, Postgres. Look at the license. It's 23 lines. Very easy to read. It allows you to do anything with that. It fits in the Kaizen culture of continuous improvement and learning. So it's a perfect combination. So whether your title is Postgres DBA, developer, or system administrator, this is the advice I give you at the end of the talk, is to not only talk to your colleagues, but be ready to listen. Okay? Because together you can build something important. So that's the end of the talk. I think I have 3 minutes left, so I don't know if maybe one question. No question.
How do you manage to deal with versioning of database migrations, of schema migrations?
Yes.
Maybe you can talk about best practices. You can suggest something.
Okay. Well, there's no. The beauty of Postgres is that there's no one single way to do that. So, for instance, if you use extensions, you can try and tie your schema changes into the extension. So if you have version 1, you can build the upgrade statements to version 1.1 that include, for example, adding one table, changing the type of a column. Of course, these might be tasks that introduce a lot of work and contention in the database, especially in production. So you need to carefully plan them. But for instance, with extension, you can do that. You also have transactional DDL. Transactional DDL helps you do that by wrapping everything into a script, an SQL script. I mean, we normally, because we like to version all the things we do and make all the changes permanent. So, and have a history of the changes that have been applied to the database. We use SQL files, so text files. We don't use an external tool that manages changes. So we normally deal with SQL files, and you can wrap up everything into a single transaction, or split that in multiple transactions. It's up to you, really. So our methodology is to build a very high PostgreSQL knowledge in all of our partners and customers, and we encourage everyone to always improve their PostgreSQL knowledge, because you can actually understand better how to do that by yourself. Okay, but it's nowadays, if it's simple, we might tidy it up in an extension, or you can write your own SQL files that perform the migration.
But which extension? What is the name of this extension you suggest to use?
You decide the name. You can write your own extensions. PostgreSQL is extensible, so it allows you to create your own extensions. So pardon if I can. It's a very, it was born with extensibility in mind. That's part of the reason PostgreSQL was born in the early 80s by an idea of Stonebreaker. So I think we're done. Okay, thank you.